started thinking about our project, we were given a long list of directions and ideas to take our experiment down. But the ones that immediately stood out to us were the ones that involved changing or creating materials. We saw boundless potential in this line of thinking, and the possibility to create something new and something permanently better excited us, and we knew how many people we could help if we went down this path.
Material is a very broad term with many problems to be solved, and we were restrained to the little time and resources that we had. Eventually, we zeroed in on metals. We found there had been previous experiments done to strengthen metals, by melting them and resolidifying them both under microgravity and in a separate trial under magnetism. Both these experiments had successfully strengthened the metal, so we decided to combine these treatments by melting the metal and then resolidifying it in microgravity and under a constant magnetic field.
First and foremost, we can take a look at the containment unit of our entire experiment. In this case, we decided to 3D print our box using carbon fiber filament for the best weight to strength ratio. 3D printing it also allows us the added advantage of including built-in compartments to better secure all of our components to the box.
Next up is the Arduino, which is the central control unit of all the functions in our experiment. It is triggered by the accelerometer, which is mounted into a form-fitted container, which is also printed onto the box.
The Arduino is powered by a 9-volt battery, which then outputs 5 volts directly into our induction heater. We chose induction heating for its efficiency and safety and its ability to heat the chosen metal to 62 degrees Celsius, which is its melting point.
Once the payload has reached microgravity, the CO2 canister then proceeds to cool the system down. While the system is cooling, the metal then reforms while under a consistent magnetic field produced by the two magnets.
If we succeed, it can have many widespread benefits across many fields. Astronauts would have more security in their spacecrafts with stronger heat shields. Circus and wire rings would have more efficient, and therefore benefit communications. And we would need less materials to build sturdy buildings and thus conserving our planet's natural resources. Looking at the benefits and results, our experiments can induce further studies and milestones in testing metal alloys in microgravity.